What came next was heat, more than any calculation had dared predict. The model said that at 12 kilometers, temperatures should hover around 100 degrees Celsius, maybe a little higher. That seemed manageable. Steel could take that. Instruments could take that. But when thermocouples finally stabilized at depth, the reading was closer to 180. That number looked like a typo. Then a second instrument confirmed it. The borehole wasn't warm, it was furious. The first sign of trouble came when drilling mud began to hiss. Fluids pumped down to cool the bit came back up slightly fizzing. Its viscosity changed. Samples extracted at depth sizzled in contact with the Arctic air, releasing thin curls of vapor that smelled metallic. Within days, the drill head started deforming. It wasn't snapping or shattering, it was softening. By all physics of metallurgy, that wasn't supposed to happen at those pressures. But down there, laws failed politely and then stopped showing up. One engineer described watching a freshly pulled bit. Its edges shimmered, glowed faintly, then sagged like wax. They dunked it in snow to cool it, and the snow melted instantly. The team measured the returning mud temperature, 80 degrees. That was the fluid meant for cooling. It came back scalding. At that point, they realized the earth itself had turned hostile. The deeper rock wasn't brittle anymore. The drillers expected cracks, fractures, explosions of dust. Instead, they found pliability. The rock around the bit behaved like dense clay, squeezing inward slowly, closing behind the shaft so that each time they paused drilling, the borehole began healing itself. The word that surfaced in the reports was plastic. The crust wasn't static, it flowed. In the control cabin, gauges began to twitch erratically. Torque fluctuations that once indicated small variations now jumped whole orders. Pressure sensors sounded alarms without obvious cause. It wasn't equipment failure, it was the environment changing second by second. The operators could almost feel the hole breathe beneath them, a soft surge as heat expanded trapped fluids, then contraction as it cooled. The planet was flexing around their intrusion. They tried every engineering trick available. New drilling fluids with higher boiling points, more robust steel alloys, thermal isolators. Nothing lasted. Electronics fizzed out after minutes, insulation baked away. The scientists joked grimly about cooking their instruments in Earth's oven. Repairs became daily rituals: rewire, replace, recalibrate, hope. For every meter gain, another sensor died. Then came an unnerving discovery. Even with active drilling suspended, temperature in the borehole kept rising. It was as if each rotation of the bit unlocked deeper heat that refused to dissipate. Thermal models predicted gentle gradients. Instead, Kola's gradient spiked violently. That suggested something fundamental about heat transfer in the crust was wrong, or that some internal mechanism was trapping energy. Both answers meant rewriting textbooks. Field reports grew more poetic as frustration deepened. One technician wrote, "The rock pulses." Another noted that gravity readings near the site began fluctuating ever so slightly during drilling periods, a few microgauss difference, far too tiny to prove anything but enough to make people wonder whether expansion of heated rock could distort measurements. Geologists spent long nights staring at cross-sections, trying to understand why heat built faster with depth than predicted. One theory blamed water. Maybe the fractured crust had trapped ancient fluids under immense pressure, turning them into superheated steam. Another theory said the thermal conductivity of the metamorphic granite changed dramatically under compression, channeling heat unevenly. None of it explained why every tool designed for hundreds of degrees failed at barely half that. The psychological toll mirrored the mechanical stress. 12-hour shifts became 12-hour standoffs with invisible fire. Workers emerged from the rig room flushed and trembling, as if they'd wrestled the planet. Sleep deprivation bred hallucinations of vibration through metal walls. Even off-duty, they said they felt it, the hum in the ground like heat-made sound. It wasn't supernatural. It was conduction, convection, expansion. But knowing the science didn't make the sensation less eerie. Progress shrank to centimeters. The borehole walls smoothed into a glassy surface, compacted by pressure. Attempts to reinforce them only made it worse. Injected cement boiled, cracked, then squeezed upward. The deeper they went, the faster the earth erased their work. When they tried to resume drilling after a brief mechanical pause, the bit jammed in place. It took 3 days to free it. The data recorded during that stall became infamous, oscillating temperatures seemingly climbing, falling, then climbing again as if the rock's heat was alive. By that point, rumors circulated among the crew. Some swore that if you put your ear to the drill column during operation, you could hear low moaning noises. Rationally, everyone knew it was harmonic resonance from rotating steel. Emotionally, it sounded wrong, long, wavering, almost vocal. Those were the sounds that later fed the myths. Someone taped them for analysis, and once copied through degraded analog equipment, the result resembled human cries. That recording, traded later between radio hosts, became proof of the screams from hell. No one at Kola believed such nonsense, but they couldn't deny that what they heard unsettled them. Science was the new superstition, and it terrified just as thoroughly. When Moscow analysts reviewed the final month's data, they were stunned. The Kola temperature curve defied every geothermal model used in academia. Instead of stabilizing with depth, it bent sharply upward, implying that at 15 kilometers, the temperature would exceed 300 degrees beyond any known capability of drilling systems. In a single stroke, the project reached not the mantle, but the ceiling of human endurance. Inside the rig, the heat changed behavior in strange ways. Lubricants ran thin like water. Metal joints expanded so much that bolts refused to fit. Some mornings, ice crystals formed on the rig tower from Arctic wind, while the borehole directly beneath steamed like an exhalation. Two climates meeting at one point, a frozen desert above, a furnace below. Eventually, the command came to halt operations. Officially, the reason was budget and technical reevaluation. Unofficially, the scientists had no path forward. Every method of extension risked losing the entire borehole to collapse or melt. As the last sections of tubing were pulled and sealed, the site felt less like a laboratory and more like a shrine. They had reached 12,262 meters, and at that depth the planet had answered in heat, not words. Standing beside the cap shaft, one senior geologist said quietly, "It feels like the ground is breathing through it." They didn't mean metaphorically. Residual convection kept faint waves of warmth rising through the metal. In the frigid air, it shimmered like mirage. The hole exhaled. Humanity inhaled wonder and defeat. For the team, this wasn't failure. It was revelation. The Earth had a defense mechanism, temperature itself. Beyond a certain depth, matter stops behaving as a solid and starts acting like memory, bending, reshaping, erasing intrusion. They hadn't just found limits of technology, they'd touched the physical form of uncertainty. Later analyses confirmed what the crew already sensed. At around 12 kilometers, rock transitions from brittle to ductile. It creases instead of cracks, like muscle rather than bone. That's why it tried to close around a bit. That's why temperatures rose uncontrollably. They had breached not a geological boundary, but a philosophical one, the point where the Earth refuses to remain predictable. When journalists later asked why they stopped, one engineer answered, "Because the planet melted our science." It sounded flippant, but it was literally true. Every calculation dissolved into that heat. As the Arctic night closed over the silent rig, the metal tower gleamed faintly under stars that never set. Beneath it, miles of instruments now frozen in inactivity led to a chamber of slow-moving stone, still warm, still healing. The Kola Superdeep Borehole was no longer a project. It was a scar. A reminder carved 12 kilometers deep that curiosity burns just as fiercely going downward as upward. The space race had left footprints on dust. The Earth race left nothing. The hole sealed itself, almost tenderly, as though the planet preferred silence. And up on the surface, a scientist stood in that silence, realizing the truth that would haunt every future drilling attempt. The Earth doesn't yield knowledge. It resists it. We didn't lose the technology or money. We lost the heat, the purest form of the unknown. The inferno wasn't mythic at all. It was geology defending its secrets. Section 5, Fossils in Hell. After all that chaos, heat, pressure, and deforming rock, the last thing anyone expected to find was life. Not living, not breathing, but proof that it had once existed where life should never have been. 6 to 7 kilometers down, cores from the intermediate depths revealed something on their surfaces that looked wrong in a way science loves. Clear, undeniable, impossible. When the first cylindrical samples were hauled up, coated in translucent drilling mud, nobody noticed anything unusual. The routine was simple: slice, catalog, photograph, archive. But under magnification back in the field lab, one petrographer stopped cold. Embedded in the metamorphic grains were oval shapes, delicate outlines, sequences repeating like stamps. A few more slides later, the microscope showed entire structures, cell walls, ridges, even traces of once organic carbon. The samples were teeming with forms that looked biological. 24 species they would later identify, all dating to nearly 2 billion years ago. That number staggered the team. 2 billion years, back when oxygen barely existed in the atmosphere, long before multicellular organisms. Yet here were microfossils preserved inside crystalline rock, sealed beneath layers of mineral compression that should have destroyed everything. Scientists held the thin rock slices to fluorescent light and whispered profanity usually reserved for miracles. The fossils were found between thick veins of metamorphosed sediment, so crushed and heated that it seemed absurd anything recognizable could survive. And yet under thin film analysis, the cell outlines glowed faintly with traces of carbon and nitrogen. Those elements suggested biological origin, not random mineral growth. What terrified and thrilled them simultaneously was location. 7 kilometers deep is not supposed to contain remnants of surface life. Geological law said such layers should have recycled ages ago through tectonic subduction. Ocean sediments become mantle feedstock, melting and re-emerging as volcanic flows. Nothing should preserve fossils at those depths for billions of years unless part of the planet had stopped obeying recycling. That tiny discovery hinted that Earth's crust might not churn as efficiently as scientists believed. Pockets of ancient surface matter still rested untouched in the deep. As word spread through internal channels, disbelief rippled through Moscow's academies. Some claimed contamination, mud circulation could have dragged modern particles downward. The field team double-checked everything. Sterilized containers, control samples, isotopic dating. The isotopes fit Precambrian timescales. The fossils were no modern intrusion. They'd been entombed before animals were even a concept. Out on the Arctic site, the revelation changed the mood. Where before there was frustration, now there was all tinged with dread. The Earth had not just fought them with heat, it had begun whispering its own history. An ancient black shell converted into metamorphic schist, the scientists found traces of the planet's first breath. To reach them, they had scorched through voids of hydrogen gas and plastic rock, surviving conditions that melted steel, only to expose ghosts of microbes, perfectly preserved. The questions multiplied faster than answers. How did such fragile forms endure pressures of 200 atmospheres and temperatures over 100 degrees? The organic shells were supposedly surrounded by a hydraulic lattice of mineralized silica that acted like armor. Still, those pressures should have crushed everything to dust. One geologist compared it to opening a lava lamp and finding snowflakes intact. As specialists from Leningrad arrived, they carried portable spectrometers and skepticism. Within days, skepticism turned into obsession. They confirmed layered coatings of carbon compounds, residues of once living cells. Each microfossil mirrored documented species from shallow marine sediments nearly 2 billion years old, back when photosynthetic bacteria had first started flooding the planet with oxygen. That oxygen is what gave Earth its rust-red iron beds and possibly turned these creatures to stone. The deeper implications stung. The Kola Borehole wasn't just penetrating ancient rock, it was pinning down the boundary between life and non-life. Somewhere along that descent, chemistry crossed back into biology. In layers hotter than boiling water, pieces of the biosphere had survived. And if they could persist there, buried beneath eons of pressure, maybe life was more tenacious and more widespread than believed. Some nights the scientists joked uneasily. "We dug to hell and found bacteria," one said. "Makes sense. Everything starts small." Others found themselves staring too long into microscopes, hypnotized by the delicate spirals of something that had lived and died before mountains formed. The fossils felt like eyes watching through time. News of life deep underground escaped the usual censorship loops. Western media caught fragments from international geological conferences and ran wild headlines: "Soviets find life in fiery abyss." Overnight, mythology returned. Rumors blurred science and fear. Some claimed the Kola team had discovered living organisms still riding under heat. Others suggested radiation mutated colonies. Reality was quieter but somehow stranger. Mere imprints of once living things, etched in rock where no ocean had touched for eons. Among younger researchers, one uncomfortable idea emerged. Perhaps those fossils weren't trapped relics, but representatives of an ancient biosphere still lurking deeper down. The microstructures seemed surprisingly undamaged, as though the process of preserving them happened fast, not over millions of years. What if microbial ecosystems once thrived kilometers below the surface, using geothermal energy instead of sunlight? Decades later, scientists would find such life around deep ocean vents and within crustal rocks. But at Kola, this theory sounded like heresy bordering on mysticism. And this discovery did something subtle. It blurred the frontier between geology and biology. For the first time, biologists found themselves consulting drilling engineers about the limits of temperature tolerance. If life's ghosts existed at 7 kilometers, maybe life itself could endure even deeper. Each new discussion turned the borehole into something cosmic, a stand-in for every unanswered question about habitability on other worlds. NASA and ESA archives show later that fragments of Kola data influenced astrobiology protocols. When searching Mars or Europa, scientists began considering that fossils might be locked not on the surface, but far beneath, inside rock grained by heat. Humanity's first window into life beyond sunlight came from that frigid Soviet shaft that accidentally reached what amounted to Earth's first tombstone. But in 1984, none of that was clear. All the team knew was that under a microscope lay evidence that the planet never fully cleans its history. The past, one researcher wrote in his log, is alive and waiting if you dig far enough. It sounded more like poetry than science, but that same sentiment found its way into Soviet journals months later under academic phrasing, evidence for preservation of biogenic microstructures at ultra-deep metamorphic depths. Translation: fossils in hell. Back at the drill site, the discovery became almost personal. Each time new cores surfaced, technicians held their breath, peering for additional traces, the curve of a cell wall, the lattice of filaments. They found plenty, enough to suggest whole sheets of fossilized mats stretched deep in the crust. And every time more samples arrived, the air inside the cramped lab felt heavier, as though they were trespassing in sacred ground. This wasn't just geology, it was resurrection. But fascination carries consequences. The revelation revived the very rumor that had once embarrassed them. Warm tabloids fused two facts, the mythic screams from hell and the real fossils, and declared that Soviet scientists had discovered lost souls turned to stone. The researchers laughed, yet none denied the symbolic power. Earth's depths indeed held ghosts, just not the kind holy books described. These were ghosts of ecosystems, echoing across epochs we barely comprehend. Through microscopes, through rotting paper reports, the image became unforgettable, microscopic fossils suspended in metamorphic glass like constellations frozen in rock. Proof that even buried under unthinkable pressure, traces of life persist. When the site later cooled, long after drilling halted, one technician returned alone and described leaning against a sealed borehole cap, warming his hands from the faint rising air. He said it felt like the planet itself exhaling. Beneath that breath were remnants of everything that ever lived, condensed into dust, memory, and carbon, the inheritance of a world that refuses to stay dead. In the end, those fossils changed more than geology. They altered our measure of mystery. They reminded every scientist who touched them that the line between myth and science is often drawn by temperature and stubbornness. And as the laboratory lights dimmed on that Arctic plateau, it became clear why the discovery stirred so much awe. In trying to reach the mantle, humanity instead found its own origin story, written in cells that had outlived continents. The Earth wasn't hiding horrors in its depths. It was preserving history far longer and far deeper than we ever imagined. Section 6, the gases from below. They thought they'd reached the end of surprises, but then the Earth started whispering gas. In the weeks after the fossil discovery, every new core extraction came with faint hissing sounds when the pressure seals cracked open. At first, nobody cared. Gases are common in boreholes, remnants of trapped air or hydrocarbons. But these were different. The release was intense, almost violent, like opening a carbonated bottle the size of a mine. Vapor burst upward with a roar, strong enough to fog the laboratory windows despite the Arctic cold outside. The smell was metallic, sharp, something between ozone and wet stone. Within seconds, the lab filled with condensation that condensed into shimmering droplets on every surface. Someone measured the composition. That's when patterns began to fall apart again. The gas wasn't mostly methane or carbon dioxide as expected. It was hydrogen, nearly pure, over 15% concentration in some samples, more than 1,000 times higher than predicted. It came in pulses, surging from fractures in the deep core sections as if released from pockets under tremendous pressure.